To talk about sensing color with the Circuit Playground. Someone asked me if there was a way to sense color in class today, and I couldn't remember. I know there's color sensors out there, but I couldn't remember if there was one built into the Circuit Playground, and there's not, but there is a hack that works so well that it's actually built into the library for Circuit Playground. So I wanted to show you quickly how that works and how I figured this out. So the first thing I did was I just looked in the examples for the Circuit Playground library and color sense. There it is. Sensing color, which is this code. So I'm going to walk through that, but before I do, let me just demonstrate what this does. If we take an object, like pen, and hold it over the light sensor, so where it says A8 and there's that eyeball there, and press any of the buttons, it'll scan and sense the color and then turn all the neopixels to be that color. So there's my blue pen. If I take some red end cutters, there we go, red. So if I don't have anything there, we can see what it's doing. It very quickly flashes on the A1 neopixel, red, green, and blue, and it uses, and then it reads the light value on the light sensor for each pulse, and then it aggregates that to determine the color. So let me look at that. In the code, we're including the Circuit Playground library, SPI, and wire as well, though I'm not convinced we actually need those. We'll see. In the setup, we're just starting serial communication and the Circuit Playground, and then setting the default brightness to 255. In the loop, they're doing an interesting thing to detect the button press here. They're doing first left, first right, and second left, second right. For the button reads, and they're using the library to do the button reads here too. So Circuit Playground dot left button to read the left button. And then in this conditional scenario, okay, so if the left first is true and left second is not true, or right first is true and right second is not true, run this code. So that's a way to detect the either a press or a release state. So it's like edge detection. It's detecting the change of state, because only when these two things are not true or are different from each other, excuse me, when one is true and the other is not true, do we have an edge, because then they'll be the same. So that's just detecting when exactly the button is pressed or released. So all of that is to say it's a different way of doing debounce. So then for the actual color sensing, first thing we're going to do is turn off all the neopixels. We're going to have three variables called uint8 underscore t. So these are an integer that's unsigned, and I believe we're limiting it to 8 bits. I'll have to double check that. But the U is unsigned, so we're just dealing with positive numbers, and we're saving memory space by using smaller variables than the larger integer type. One for each color channel, red, green, and blue. Circuit Playground.ColorSense is where we're actually detecting the color, and we're giving it those red, green, and blue variables. It doesn't return anything, so we're not setting anything equal to this, but it is going to change those three variables. Then we're printing out, as you can see down here, the color, red, green, blue, and the numeric RGB values for those, 8-bit values. And then the last thing we're going to do is set the red, green, and blue gammas. So that's a way to do a little bit of like color correction and tuning, as you can see here, make the LED brightness appear more linear or more related to the object we're scanning. And then finally, we're going to make all the neopixels that color with this for loop that's going to go through all of the neopixels and set their RGB values to our red, green, and blue values. And so again, we're looking at these colors here, right? If I put the pen on and click, we get red, green, and blue. Red's low, green is highest, blue's in the middle, and that's how we get that cyan color to match the pen. Versus if we do the handle, the plier handles, red is highest, green and blue are equally low. We get the red color. So that's pretty much it. That's a way to do color sensing with the Circuit Playground. I was curious about this technique because that is just a light sensor on there. So I looked up this equation in the GitHub, reference. And so I'll talk briefly about what it's doing too, because it's surprisingly simple. We've got the function sense color. It doesn't have a type. It doesn't return anything. But notice here, it specifically wants these uint8 type variables, and it's accepting like the ampersand beforehand. So it's accepting like a pointer to that variable space, so that when it changes those red, green, and blue values in the function, those variables get changed. So that's not the typical behavior for arguments of a function. Usually you send the arguments into a function, and you can do whatever you want to them within the function, and they're not going to change outside of it. So this is different from that. That's how we get around needing 3 different variables to be returned or updated. The first thing we're doing is setting an old brightness variable to whatever the current brightness is. That's just a way of recording the current brightness state, and so we can return it to that, because to detect the color, we're going to set the strip brightness to full. Then in short procession, we're going to set the pixel color of just that 1 pixel to full red, delay this light settle milliseconds, which is very fast, and then we're going to record into a variable called raw red from the light sensor. So we're calling the light sensor function and reading that into raw red. Notice here we've got uint16, so that's a 16-bit unsigned integer, because the light sensor is going to give us what is actually a 10-bit value back, the 0 to 1023 value, but that will not fit in a uint8. Then we're going to do the same thing for the green and for the blue. Okay, so then we've got these 3 raw analog values, and so what that's doing, right, is it's setting the neopixel there, that 1 neopixel, to be full brightness of 1 singular color, like red, and then reading the light sensor. So if the object is red, it's gonna reflect, right, all that light. Otherwise, it would be absorbed. Whereas if it's blue, it's going to react to the blue light differently than the red light, and differently from the green light based on the color of the object. So then we turn that pixel off, we restore the old brightness from up there, and now we're going to scale our values and to set these to 0 to 255 because we want an 8-bit color RGB color value. So we could use a mapping function to do that, or we could just say whatever that raw value is divided by 4, because 1023 divided by 4 is 256 or 255. That will give us the value, and then they're doing this minimum whatever is less of 255, and that computed value just to as a way of like clipping or to keep this value from possibly going above 255. And that's it. That's it. So those values get set because of how these are pointed, and then we can do our gamma correction and turn the pixels on based on those colors. So it's a really interesting way to use because the board has those neopixels built in that are RGB, we can use reflected light to measure the color of an object.